And also the number of participants. There's some voices, not from me. The number of participants in audience make me feel very excited. Many thanks again. Let me introduce. Let me introduce my university, our department. Also, very short introduction. So I'm from Ege University in Izmir, Turkey. So Izmir is located western part of Turkey. We are in front of the Greece. So Izmir is one of the third biggest city in Turkey, and our university is also one of the oldest and biggest university in Izmir. So you can see some views from our university. Here is Egematal is the research center where we are working. So we are working focused mostly on utilizing nanomaterials and biofunctional surfaces in sensing and drug delivery applications. So after pandemics, of course, it has already started just before the pandemics. But through the pandemics, we are hardly focused on POC system, different point of care diagnostic. Based on fluorescence or electrochemical measurements integrated with the smartphone. So these are some views from Izmir. So as we all know, during the pandemics, we prefer to be in open air and at beaches and so on. So I would like to share some also other images to show some of nice places. Okay, my outlines will be materials for sensing applications, surface design, nanomaterials, and also our data on pandemic biosensors for COVID-19. And if I have a time, I will shortly mention on abuse drugs biosensors. Materials for sensing applications are focused on design, synthesis, characterization, and modeling of novel functional materials and architectures used in detecting the chemical environment. These are surface chemistry, playing surface chemistry and bioconjugation reactions are the main steps or key steps for all biological recognition-based sensing or some other works, again, based on the host-guest interactions or some specific recognition reactions. And to create functionalities, the selection of chemical or biological groups are also crucial because at the final design, it should be able to recognize specifically or selectively to the desired molecules or target analytes. Different chemistries could be used for the integration or absorption of these molecules into the structure, and also multifunctional surfaces are of interest, especially in last years for different sensing or therapeutic applications. Let me show some applications used in bioconjugation reactions. We can use this chemistry, this chemical pathways for labeling, conjugation, modification, or immobilization, biomolecule immobilization, which is also very critical to obtain high performing sensing system. It seems that I like this photo very much and use almost in all my presentation because it is mostly summarized the requirements. So integration of various biomolecules and nanomaterials on a active surface, it would be either electrochemical or optical or paper-based substrates. So it seems to be like the marriage of convenience, and the most important thing in this kind of systems are optimization studies, because some different some molecules with different. So this is a very important step to obtain highly performing sensing and recognition properties. These are nanomaterials used as this kind of various kind of bioapplication. We prefer generally fluorescence molecules or optical systems, optical label visualized by naked eyes also, especially in lateral flow tests. So quantum dots, polymeric structures, and some gold nanoparticles, and so on. These are what I will mention into this presentation. So on related with this subject and use of increments in use of POC system, especially clinical diagnostic, also some in situ applications, environmental detection of some pollutions. Paper-based systems are very important, especially when we integrated that system with a smartphone. We obtain smartphone sensing. And for the smartphone sensing, we need the signaling molecules and functional nanoparticles that would be mainly functional nanoparticles. And it seems that these are bridges from smart services to global health. So we can collect data at the lab bench and use them for the global health applications, clinical applications at work or at traffic, at home. During the pandemics, it's the most requirement is to use that kind of system at home, especially to reduce the number of patients. It was necessary. So that we reviewed test applications in 1980, and it was covered at analytical chemistry. So I'm very proud of this paper, because we also put the nice view of my city into the cover of this valuable journal also. So these are some papers from our group on clinical diagnostic, smartphone sensing, and also abuse drug sensing. I will mention some of them in this presentation. Okay, today I would like to share some our developments and data as pandemic biosensors, COVID-19 as COVID-19 related studies. These are performed at Ege University, Science Faculty, Medicine Faculty, and Research Center. And we use clinical samples. These are collected from Faculty of Medicine, Ege University Hospital, one of the biggest hospital at the region territory. So this hospital was very, very active at the pandemic situation. So the first part, I would like to mention electrochemical POC devices. This part, we collaborate Professor Khaled Salama from KAUST, and also his team, also his students. She will be almost PhD working with his group. They provided POC system, and also laser scribed electrodes. They have very well established infrastructure for production of LCG electrodes and all these activities. LCG electrodes has good electrochemical activity, straightforward and cheap. It is possible to obtain higher number of electrodes at the same time with high conductivity and porosity, very proper for the further modification or one-step surface modifications. After preparation on the polyamide substrate, gold nanoparticles are electro deposited on the surface. We prefer to use this kind of surfaces. As we all know, gold nanoparticles provide higher surface area and also compatible with the biomolecules. What is important in this recognition-based measurements, the most important thing is to protect the recognition capabilities and their binding efficiency. So it would be nicer if we prefer mild immobilization conditions or one-step or two-step immobilization. In that case, it provides very mild condition for the further application. These are a whole system. So you can see a POC device, and also it is the portable circuits connected with USB connector, and these are real dimension. So these are good for practical and real-time application in in-house or non-laboratory conditions. Let me show the very short video showing or summarizing this system. Okay. That work was performed at the beginning of the pandemic. So at the beginning, there was no clear information for it. It is valid for all of us. So we, as I have already mentioned, use gold nanoparticle detection deposited LCG electrodes. These are surface modification with antibodies specific to COVID-19 virus. And it is possible to make a drop of sample measurements and also also evaluate this data by using a smartphone system. So in the case of preclinical studies, POC devices developed in this part, we compare our data with RT-PCR, that is gold standard, and also with other tests, ELISA tests. So what we can find is that cost diagnostic system or POC system has 100% agreement with the gold standard, and when we use commercial ELISA IgG or and IgA tests, these are only 65% and 74% in agreement with this standard. So it means that it works well, and we are still working to make some improvements together with in that group, Professor Salama. So this is our surface, this positive, when we use the positive serum or positive samples and negative patient samples. As you can see, there's a binding, and as a result of this binding and interaction, these are DPV signals obtained in the presence of redox probe hexacyanoferrate. This is in the presence and absence of sample. You can see the reduction in the signal, electrochemical signal. And in the case of negative patient serum, you can see the difference. And when we compare two difference, okay, this is negative and this is positive, we can say that it works successfully. So at the final step, we are trying to validate the POC system, and we compared it commercial potentiostat, pan-sense potentiostat. Of course, there are some noises. There is no correction was made directly. We put our data, so we can see the same trends. And redox probe, in the case of negative samples and positive samples, we obtain the same trends in this signal reduction. And as a continuation of that work, we developed a system for variant recognition, because at the beginning of pandemic, we can only obtain samples without modification, without mutation. So then alpha and beta variants, then delta, omicron, and so on. And then at that time, alpha and beta and no mutation and control patients are compared, and higher selectivity to SARS-CoV-2 alpha and beta variants among other also respiratory viruses are obtained. In that case, as I've already told, 40 patients were tested and compared with RT-PCR. And you can see the difference between negative, alpha, beta, and wild type virus. So again, COST POC has 100% agreement with the gold standard. And there is some other characterization steps. Then if you are interested, I can share after that to keep the time. So I passed it. But one of the important data is that the selectivity of the system in the presence of other respiratory viruses. This is important because after the pandemic, it mixed. There's a very complex situation. So influenza, other respiratory virus, H1N1, they all mix. So variant detection or detection of other respiratory viruses are of interest. So we are working on that subject also. And also this system is connected a tiny machine learning tool. So it is tiny machine learning enabled POC device it became, and then different data are obtained and evaluated according to their mutation. So at that time we have no delta and omicron. We just all these variants are something like that. Also, another system, not electrochemical system, but my title was Shiny and Colorful Nanoparticles. At that part, we obtained naked eye visualized and also smartphone visualized test. So we colorful and shiny Let me show our structures used in lateral flow assay. Normally, in the commercial tests, gold nanoparticles are used, mostly used, but gold chemistry is a little bit strange. It is very depend on the conditions. Of course, it seems that it is easy, but you should work very precisely. It is also not so cheap. So we try to develop or synthesize an alternative tools, alternative molecules. One of the alternative was synthetic molecules with the polymeric structures. We can adjust the size and we can choose the color because we can encapsulate various dyes into these structures because it can be synthesized amphiphilic block copolymers. It is in spherical shapes vesicles. So after synthesis, we obtain different polymerasome systems are obtained with pink color or blue color. I will show later. And the second difference of this system from the others is one of our group of our group leading the professor Professor Figen Zihnoğlu and her team purified antibodies and antigens from the patient samples. So what does it mean? When we use this procedure, we can obtain, especially in the further studies, it is very important for the variant detection. Different samples at that time, for instance, if delta or beta are available mainly, you can obtain that variant specific antibodies by this affinity-based purification. That part was purification and also characterization of their purities was performed different ways. So what we used 61 serums and 60 nasal swabs, positive and negative swabs are used. Negative are used as the negative control. They first classified, and positive samples are used for antigen and antibody purification. And another part of our group, Faize and others, my Kerem, also Hisham again, polymerisome preparation for lateral flow tests to obtain sandwich, either sandwich LFA or competitive LFA for antibody diagnosis. I skip that because these are characterization of synthesized polymers. And the next step was validation and characterization of purified antigen and antibody. We all know we classified them as low, intermediate, and high virus charge. So then compare their efficiency, their recognition efficiency. Negative and positive samples are also compared in terms of sample distribution. These are purity control. And this is design of our test. This is for antigen diagnosis and antibody diagnosis. But we mainly used and continue this antigen diagnosis because it is more important. It is more important to detect antigen at work, at home, at where you want, because it's especially in the markets, we can see day by day the number of antigen tests are increased. So these are what we have done. There is in the test line, we put antibody and non-specific antibody, then apply the sample and labeled again with the targeted polymerosome. If it is a positive sample, we can obtain 2 lines, and if it is negative samples, we obtain only 1 line. So we also compared their accuracy. Many tests are performed, but overall diagnosis, in terms of diagnosis accuracy, 93% was reached. So these are negative and positive samples. But was the interesting thing, its accuracy was almost depending on the virus charge. If the virus charge, how we can know it? We can know it's according to PCR data, PCR cycles, CT values. In the lowest virus charge give the worst result, because it is normal, because it is mainly important their cutoff values. It can be also adjust more to change to increase their accuracy. So these are analytical validation, both for antigen test and antibody test. Roberto, I don't know about something in my time. Have I time? More time? Okay, I have, as I see. So another dot blot assay was also performed with by Faize, Hisham, and with the other person in our group. So let me have obtain some interesting data, because it's also very easy to establish the system. Our objectives were to synthesize nanomaterials, alternative nanomaterials, different nanomaterials, to ignore the use of gold nanoparticles as more cheaper and for easy use, or stable materials, because it is very affected on the stability. Some of tests we can see, commercial tests, aggregation can occur, and they couldn't work. So our works, one part of our works mainly focused on the alternative nanotools, nanomaterials. I would like to show the dot blot assay, the principle of the assay. First, anti-spir protein antibody was spotted on the nitrocellulose membrane, and the sample was applied. And at the final step, we tried different nanoparticles, polymerosomes and gold nanoparticles, and an addition reactions to make them more stabilized. So what we found, this is the surface chemistry for gold nanoparticles, cysteamine, and then amine as high affinity to aldehyde. After incubation, we obtain that structure. So 3 different options are tested: gold nanoparticle plus stabilizing reagents with hydroquinone and silver, and polymerosomes, our synthetic materials. So these are data not so visible, but you can see gold nanoparticles, our dot blot assay with gold nanoparticles. After reagent treatments, darker spots are obtained, more stable and darker spots, and polymerosomes. So plot calibration, and as you can see, polymerasomes provide and better plot, better linear plots in comparison with the others. So this is the reason why we continue this structure instead of gold nanoparticles, and also, of course, this is better gold nanoparticle plus the hydroquinone silver nitrite reagent, but since we can play their features, we use to continue we continue to use polymerisomes. These are some tests, because at the final step, we took their photos, and image type free color analysis program was used at the smartphones. So as a result of them, we calibrated according to their, three of the system was calibrated according to their color densities, and compare with PCR CT scores, which are always used as the gold standard through our studies. And different polymerisomes and also gold nanoparticles. And different conditions are also applied. Different megapixels are used to obtain better images, better quality of images. Also, lamplight, daylight was also tested. Many parameters are tested in lab. Both positive, these are difference between positive and negative samples in the case of using the different systems. So similar systems was a similar system was also fabricated by using other fluorescence polymer, synthetic material, using polypyrene grafted polyepsilon caprolactone, prepared by simultaneous photoinduced step growth and ring opening polymerizations and neo reactions. This part was performed by Professor Yusuf Yağcı at Istanbul Technical University, and we just functionalized this fluorescence polymer and use to spot them on nitrocellulose membrane to obtain a dot plot assay. Also, we can also obtain these results under UV lights. We can see the difference between negative and positive samples, and these are also the color density is related with the virus charge or virus load. These are characterization of synthetic parts, and these are the another image showing our surface nitrocellulose membrane, antibody spotting or immobilization, sample application, and then at the last part applied to antibody conjugated polymers, and there is a difference between negative positive samples, and also depending on the concentration. These are some images and fluorescent macroscopy images. What happened when we apply the polymer conjugated antibodies, when we apply the negative sample and positive sample, and how is their fluorescence images, we can easily see the difference between fluorescence images and SEM images between negative and positive sample treated surfaces. So different materials, different synthetic materials could be tested in terms of their performance, their recognition performance. In that case, we only tested negative, positive, and positive UK variants that has been already available. Depending on the pandemic stage, we collected that samples from the hospital, and their characterization analytical features were detected by using biosensors validation characterization steps. So I would like to skip sorry this part, some data on abuse drug detection. Maybe if some students, maybe young scientists are interested, I can share that also data. Finally, first, I would like to thanks for your attention, for your patience, and Roberto, dear Roberto, many thanks, and organizing committee, many thanks for giving this opportunity to me, and also maybe final and maybe last but never least, my students, my collaborators, and also my university, TÜBİTAK, for financial also state planning. Uh, and also our center. So I hope I can finish. I finished in time, Roberto. Okay, thank you.